Welcome to Physics 2210 Exam 2. This is the correction of the exam. Some points that were missing or I got wrong in the exam. I'm going to begin with number 3, where a mass M, you have like a mass, an object, which is basically standing on a table, and it says that is pulled along a rough table at a constant velocity. So this table is rough, right? And it says that it's constant velocity, being pulled by a constant velocity by an external force. So this external force is pulling the object. And it says that we don't know this angle, we don't know basically anything about this force, but we know that the velocity is constant, so the net force in the system is equal to zero, right? There is no acceleration. There is a speed, but it's a constant speed. And basically, a problem give us also a free body diagram. It has the force of friction, normal force, the force of gravity or mg, and has this force here pulling. And it says what of the statements are true. One of these statements basically is asking us if mg is bigger than the normal force, or the normal force is bigger than and the friction force is bigger than the force exerted here on the object. And I basically answered that at first. That on the exam I got it wrong because I answered that basically we didn't have any every force. It couldn't have a force bigger than the other because the net force was zero, and basically if the net force is zero means that the all the forces are equal, but that's not true because for the object to be moving at a constant speed, this external force or exerted force has to be bigger bigger than the friction force, so the object can move. Because if this force here in the x basically in the x coordinates when be bigger or equal to the friction force, the object will move. And then we'll have that basically a normal force here has to be less than the force of gravity. Why we know that? Because this force has a component in the y also, and this component makes it so normal force is smaller than the force of gravity, so the body can move and have like a constant speed. Okay, going next to the next question that I got wrong. Had basically a car present us with the idea of a car around a circular curve. So I'm just gonna draw that, and basically it says this is roughly uh, draw of a car, and it says that what is true for that car that is going on a circular curve. And it's important to say that this curve here or the road is not banked, or basically that is just level. And basically, I answered that there is no net frictional force because the road and the car exert equal and opposite forces on each other. But that's not true. When if there's circular motion, there has to be an acceleration inward that is going inward. That's what we call the centripetal acceleration. And in this case, if we draw a body diagram, we have seen from basically from the side. Let's see, this is the car. This is the normal force. We have mg, and that's basically zero. They cancel each other out. But we have a force going here that's creating our center. When this car is spinning, is creating a centripetal force, and this force in this case is the force of friction that opposes or that is contrary to the movement. And in this case, if the force of friction is a centripetal force, we got the centripetal force, or Fc, is equal to mv squared over r. So the statement that is true about this motion is that the frictional force of the road on the car increases when the car speed increases, because basically if this is the frictional force, if you increase it by 2, obviously the speed will increase too at the same rate. On obviously if you increase the speed by a factor of 2, the force of friction, or the force centripetal force in this case, will be bigger 4 times, or will increase in 4 times more. So that's basically the answer, was that the frictional force on the road on the car increases when the car's speed increases, because of this relation that we have here. And then I'm gonna jump up onto problem number 11, where it asks us about, we have a medium-sized jet. I don't know. I will draw a jet like that. Probably this is like an airplane, a plane more like a jet. But anyways, it says that it has a 3.8 meter diameter of fuselage. So this is the diameter, and it had a mass of 85,000 kilograms, and the shaping that it gives, shape, is equal to 0.32, and it asks us how much thrust must the jet's engine provide to cruise at. So basically it had to have a constant speed of 250 meters per second, and an altitude where there's density, so P or phi, I guess, is equal to 1 kilogram meter cube. And then we have that basically you go by, if you want to know what's the basically how much thrust you need to equalize on this problem the force of drag, because the force of drag is basically going in the opposing the forces of thrust, or the forces that want to make the airplane go forward. So force of drag is equal to 1/2 c, which is the constant, b, which is the density of the air, a, which is the area, and v is the velocity to the square. So what I got wrong in this exercise, basically they give you all the information you need. You just need to divide this 1 by 2 to get the radius. And you need the radius. Why you need the radius? You need the radius to get the area here of the shape, because we know it's a cylindrical, it has to be a circumference, and the area of a circumference is equal to pr squared. That's what is the mistake I did, because I got, instead of using pr squared, I used 2, I think I used 2pr as an area, and that's just the length of the circumference, is now the area of the circumference, and that's what you gotta do here. So when you plug in all of these numbers and you calculate the area, you get that the drag is 1.1 times 10 to the 5th newtons. And that's basically it. It's pretty simple, but you have to make sure you plug in the correct information, because just incorrect information can give you a totally different answer. And then just gonna jump out to the last question on the exam, which is number 12, and it's about basically there's like two boxes on a slope. This is A because it says A is closer to the floor, and it's on an incline of 32 degrees, and basically they ask you to find the tension in between these two. Each one of them weighs 5 kilograms, and they want to know what's the tension and also what's the acceleration on the system. And I think, well, in this case, you're gonna know that the acceleration that you want to calculate in the system is the total acceleration of the system, which is the same in A or B, is the same acceleration. They will have the same acceleration because we are dealing with a problem that this string or this rope is massless, and this will basically, the acceleration of block A will be the same acceleration in block B. I think in the problem what I got wrong, because basically I just missed just 1 point in this question, is that I used the, well, to get the acceleration, obviously you need to use a body diagram. You have like the sum of forces in X, and then I got the sum of forces in X at the end is minus G mu cosine of theta minus sine of theta equals this equals sine of theta minus sine of theta equals A. And then you plug in the numbers. What you need to be careful is that you need to use this coefficient of friction in A, because A will give you acceleration, so minus 9.8 times mu, so mu in the mu A, this is for A or block A, is mu A is equal to 0.220. So you plug in the number 0.20 times cosine of the angle, which is 32, minus the sine of the angle, which is 32. I'll give you 3.1 3.1 meters per second square. And then when you have that acceleration, you plug in the numbers and you get the t. Basically in the exam I just got here 3.5 and the tension was 2.2 and I got 2.07. It's just a misunderstanding of the problem, but that's what basically you have to get the correct answer, because you gotta know that it has a total acceleration. Also, what you can do, there's another way to solve this. You can also total acceleration, or I mean, once again, total velocity. I'm not sure if it's like this, but it's m. Okay. It's v. Yeah, basically you get that and oh sorry. Okay, that's all. That's basically it. Thank you so much for listening to me, and we'll see you next time. Bye.